Hello students, this is the second part of ionic bonding. So let's have a look at determination of ratio of sodium and chloride ion in sodium chloride. To deduce the formula of sodium chloride from its lattice structure, we can determine the ratio of sodium ions to chloride ions in a formula unit. In the lattice structure of sodium chloride, each sodium ion is surrounded by 6 chloride ions. Here you can see, and each chloride ion is surrounded by 6 sodium ions. So the overall ratio of sodium ions to chloride ion is 1:1. Hence, sodium chloride has a formula NaCl because the ratio is 1:1. So this would be the formula unit of sodium chloride, and the formula, you can also say that the ionic formula of sodium chloride. Physical properties. Ionic compounds are having a very high melting and boiling point. They are soluble in water, but they are insoluble in organic compounds. They are good conductors of heat and electricity. Now, what is the reason behind their high melting and boiling point? The ionic compounds are always having strong electrostatic forces of attraction, due to which their melting and boiling point is very high. A large amount of heat energy is required in order to overcome all these strong forces of attraction. So that's why they are having a very high melting and boiling point. One more thing, the ionic compounds are non-volatile. Volatile means a compound which can be evaporated at the room temperature, and non-volatile means a compound which cannot be evaporated at the room temperature. As all the ionic compounds are solid at the room temperature, so it's very difficult for the ionic compounds to vaporize at the room temperature. So that's why they are highly non-volatile. What is the reason behind solubility of ionic compounds in water only? Actually, the water molecules are attracted towards ions or ions. If we talk about sodium ion, so it will be attracted by the negative part or the oxygen of water molecule. So it will be surrounded by water molecule in this way, and chloride ion will be surrounded in this way. Hydrogens will be towards chloride ion. So this is how they will be surrounded with the water molecules. This weakens the electrostatic forces of attraction between the ions. As a result, the ions are pulled from the lattice structure, and the compound dissolves to form an aqueous soluble solution. In organic solvents, there is no water present in them. We know that alike solvents or alike molecules will dissolve each other. So ionic compounds are insoluble, as ions will remain tightly held together to the lattice structure. So that's why they will be insoluble in covalent compounds or covalent solvents. Why do ionic compounds conduct electricity when they are dissolved in aqueous solution or when they are in the molten state? Always remember, at the room temperature, all the ionic compounds are solid in nature. They are found as solids at the room temperature. So it's very difficult to conduct electricity, because electricity is basically the flow of electrons. So for conduction of electricity, there has to be some free moving electrons. So in solid state, there won't be any free moving electron to conduct electricity. Therefore, ionic compounds will never conduct electricity at the room temperature. So for that, they have to be dissolved in water either, or they have to be in the molten state. Then they will be able to produce electricity. In order to understand the conduction of ionic compounds in aqueous or molten states, let's look at this investigation. In this investigation, we are going to test the conductivity of sodium chloride. Here you can see in the first setup, pure water is used, so it will not conduct electricity. Whereas in the second setup, sucrose solution is used. Again, it will not conduct electricity because there is no ionization in both of them. Here sodium chloride solution is used. Sodium chloride is dissolved in water, and sodium chloride in water is used as an electrolyte in this setup, and it will lit the bulb. It means that in aqueous state or in the molten state, sodium chloride will be able to conduct electricity, but water in the pure form or sucrose solution will not be able to conduct electricity. If I would elaborate it, so look at this picture. Here, this is salt, which is sodium chloride, pouring some of water into it and making up a solution. We are having two electrodes over here. In order to make any electrochemical cell, we need to have two electrodes. We are having two electrodes, cathode and anode. These are connected with this wire and connected with this extension or battery. What will happen here, you can see the bulb is lit or it's on. Why is it on? Because sodium chloride is in we are having a sodium chloride solution over here. It is in the aqueous state. So whenever aqueous sodium chloride is used, so what will happen? Electricity will be conducted. Whereas whenever molten sodium chloride will be used, again electricity will be conducted. But in the solid state, electricity will never be conducted. Some ionic compounds and their uses. Here are some ionic compounds. Calcium chloride is called as ordinary table salt, which domestically used everywhere. We are having sodium bicarbonate. Sodium bicarbonate is basically called as baking soda domestically, and it is used in cooking as an anticide or for baking products it is used. And sodium carbonate is used as washing soda, which is used as a cleaning agent in detergents. And we are having sodium hypochlorite, which is an active ingredient in household bleach. So these are some common compounds with their uses. Thanks for watching the video. If you liked the video, do subscribe and share it.